Welcome engineers, Hassan here. Today we are talking about bit shift operations. Bit shift operations allow us to move bits to the left or right to a desired amount of positions. There are two different types of shifts. First type of shifts is arithmetic. Let's look at the example. If we need to shift the bit set one position to the left, we are going to copy the rightmost digit one position to the left. Surprise, right? We are going to continue copying bit by bit until we get to the last one. There is no place for it to go, so we are going to simply discard it. There is still one empty cell to the right of our array and we need to fill it with 0. And we have done it. You can shift bit sets or numbers. You can shift them 2 or more places to the left. Here, all the bits have moved to the left twice. Each shift to the left multiplies the number by 2. Right shift works in a similar way. We copy each bit going from left to right and placing it one position to the right until we get to the last bit. The lowest bit has to be discarded, since there is no place for it to go. We are left with one gap here on the left. Unlike with left shift, we don't fill it with 0. We copy leftmost bit to its place. Technically, we copy it twice to the two neighboring cells. The reason we do it is because leftmost bit determines the sign of a number and we may want to preserve it. Arithmetic right shift is equivalent to dividing a number by 2 and rounding down towards negative infinity. We will get back to this part in a second. Notice how in this example we got 0 in the left. This is because we had 0 as the most significant bit initially. In this example, however, we get left bits filled with 1s. We have shifted the numbers twice. So the two leftmost digits are now 1s. By shifting n places to the right, we discard n least significant digits. That's why we say that each right shift divides the number by 2, rounding it towards negative infinity. This is not the same as dividing by 2, which rounds towards 0. Let's say we have a number minus 3. If we divide it by 2, we should get negative 1.5. But since we are dealing with integer numbers, we need to round it. Regular division is going to return minus 1, since we round towards 0. However, right shift would return minus 2, since it rounds towards negative infinity. This may or may not be what we want, so we have to be careful with it. This is not a problem for positive or unsigned numbers. They would get rounded exactly the same way. Another type of shift is a logical shift. Left logical shift works exactly the same way as arithmetic one, so we are not going to repeat ourselves. But the right shift has a slight difference. Once again, we copy all the bits from left to right, shifting them one position to the right. We get to the last number, we ignore the last bit. And now we are left with one empty cell on the left. In arithmetic shift, we would copy the leftmost bit. But in the logical shift, we always fill those holes with 0, which makes it a little easier. The logical right shift may be used to divide numbers by 2 only for unsigned data types, or positive numbers. Otherwise, you are losing a signed bit. Notice how in this example, left bits are filled with zeros. This is the main difference between logical and arithmetic shifts. Before we wrap it up, there is one minor thing you should know about shift operators. Languages like Java and Julia have a well-defined spec and use different operators for arithmetic and logical right shifts. Many other languages use one operator for both, and the type of shift is usually determined by the data type being used. This behavior is not always well-defined and may differ from compiler to compiler. To get expected behavior, you may need to set compilation params. Always check the language specification to avoid some nasty surprises down the road. And that's been a quick overview of bit shift operations. If you have any questions or comments, please leave them down below. Thank you for watching.